In this recording, we're going to be demonstrating the deployment of a real-world OpenRiskNet application, Lazar in this case, from the OpenShift Command-Line. What we have here are three windows. One is simply a rendition of the README file in the OpenRiskNet workshop repository, and here I'm inside the WP2 Development Workshop 2019 Exercise C directory, and we're looking at the README file that accompanies Exercise C, the Lazar demonstration. I also have a command line terminal from which I'll be executing some of the commands in the exercise. And we can also see the OpenShift project, in this particular case the developer users project, where we already have a number of applications deployed. We're going to deploy an application into this user's workspace. So if we return to the README, all of the files and material are available in the GitHub repo, so I'm not adding anything extra here. And I'm already in the workshop directory on my host machine. I can demonstrate that here, which only has a very small number of files, the key one being a YAML file that describes our application. And we need to log in, but in this particular case I've already logged into the OpenShift instance, so I don't need to execute those commands. When deploying applications into OpenShift, they are deployed into a project or a namespace, which is a unique name on the server into which you can deploy your application, which may consist of containers, services, routes, a number of different objects. But essentially, in order to deploy, I need a namespace. When I'm logged into the server, I can create a namespace or project with the OC new project command. So I'll just reproduce that on the command line here. And in a few moments, we should see a new namespace, a new project appear in this user's workspace. And there you can see user 25 exercise C has been created. I can navigate into there. We won't find any objects because, of course, nothing's been deployed. So now I have my namespace, I can deploy an application into it. In the case of Lazar, that application is defined by a single YAML file which describes all of the objects that Lazar requires in order to present itself as a service. In this particular case, it consists of an image stream, a deployment configuration which describes the running container, a service which provides the container with the ability to communicate within the cluster, and a route which allows us to communicate with the service from outside of the cluster. I'm not going to go into details about any of these objects here. You can find information that describes them on the README and elsewhere in the documentation for the workshop. Here we're simply going to deploy the application. So I'll skip some of the README section here and move to the most important command, which is the deployment of the application. And that simply requires us to process the YAML file that describes our application and then create the objects that reside within it. So I simply need to cut and paste this command into my terminal here. And remember that I have the Lazar YAML file present inside this directory. And I'll just run this command now. In a few moments, we should see this project change to indicate that the objects declared in this YAML file are indeed being deployed. And there we are. You can see that there's a service, a route, and the deployment configuration is starting to take place. The ring here changes various colors to indicate the state of the deployment. Light blue indicates that the pod, the container, is being pulled and started. Once this ring turns dark blue, the container will be able to provide the service that's described inside these service and route objects. The time it takes for the container to become ready will depend on a number of factors. In this particular case, the size of the container is important. Lazar is a relatively large binary object that needs to be installed onto the machine that the project is running on. And also there may be some initialization stages once the container is running that take a number of seconds or tens of seconds before that service is actually available to receive data. And normally that might be the initialization of a database or various internal configurations that take place. Nevertheless, we get a visual rendition of the application deployment. We can already see that the service and the root exposed here through an HTTP URL is ready to go, but without the container available, there'll be no point in navigating to that URL. The number of objects that are required by your application will depend on your application. Quite often there's just a single pod, a single container, a service, and the root is optional. If your application doesn't advertise a root that needs to be a service that needs to be accessed from outside the cluster, then you wouldn't normally provide a root. And here you can see that Lazar has now declared that it's ready to receive a service. The surrounding bar has gone solid blue, and we get some relatively simple metrics indicating the current memory consumption and CPU activity of that pod. In this particular case, we're not particularly interested in those. We just now need to navigate to the application itself that's being served from this pod, and we can do that by simply clicking on this root link here. If I click that link now, we're taken directly to the Lazar REST service, and what you're seeing now is the HTTP response of that URL. So that's Lazar running for us in a container inside OpenShift. And that's all you need to do in order to deploy an application. Obviously there's a lot of complex material inside the definition of the deployment and the image streams. We're going to brush over those at this stage because, as I say, this is merely a demonstration of exercise C in this workshop. Once your application is complete, if you do not need to service any more requests, then you can finish by deleting the project, the namespace that the application resides in. And the command is reproduced here inside the README file. So now I've deployed the application, I've finished using it, I don't need the application anymore, so I'm going to destroy it and the project that it lives in. So I'll simply paste the project delete command here in the terminal window, and after a few moments the project will disappear, and it will take with it the service, the root, the pods, every object that was deployed to that namespace. And there we are, the project has been deleted.